All right. Hello, everybody. All right. All right, let's get some tunes. All right. Let's look here. Let's get some tunes going. Maybe not that one. The heck? All right, we're getting set up here. Thanks everybody for joining me. What should we listen to? All right. Welcome back in, everybody. I hope you're having a good day today. My name is Michael. Today is Sunday, October 26, 2025. Time keeps on ticking here. It was a pretty lazy day for me today. Did a lot of napping, hanging around, just recharging my batteries before we get back into work coming up here this week. So, yeah. I hope you guys are having a good day. Welcome back into the stream. Welcome back into the chat. Hope you're doing well. Let me go ahead and grab a little blanket here. All right. Let's go ahead and get this show on the road. All right. So hopefully we hit 3,600 subs today. We're at 3,593. So we're pretty close. Thank you guys so much for all the support and by coming in and hanging out. It means a lot. Okay, so today we are going to be hopefully wrapping up chapter 2 in its entirety of C Programming, a Modern Approach, 2nd edition. So this has been a good book that we've been reading, and we've been getting some good practice in so far. We are going to be coming back and jumping into chapter 2 again, which is right here. C Fundamentals. You guys can get access to my notes on my GitHub, link down in the description. If you would like to have a really good kind of review of what went down in the chapter, this is kind of what you need to know, in my opinion, for what was kind of in there. Right, so kind of a spark note, quick, do the reading without doing the reading, but obviously I think you should do the reading. Cool, so make sure you guys check that out on the GitHub and hit it with a star on the repo if you enjoyed it. Let's go ahead and open up a new folder here into chapter 2, and we'll go to the end of chapter practice problems, which are going to be right here. Cool. So let's do chapter 2. So we're going to come into chapter 2. Let's go chapter 2 exercises. Let's open this one up and let's go Chapter 2, exercise 1.c. Okay, chapter 1, 2, exercise 1.c. All right, what's going on, Badu? Do you remember me? Yeah, your name sounds familiar. I appreciate you for coming back in. Welcome, welcome. Mike wearing the mandatory Sunday shirt. You know it, repping it. Mandatory, mandatory. All right, you guys, we're going to be jumping into chapter 2 again, so welcome in. This is going to be the end of chapter problems. Remember, we already read the chapter. We went through in our first stream of chapter 2 and did the reading in its entirety. I chopped this up and uploaded it back to the channel for a condensed recording. If you want to check that out, please do so. We then, in a part 2, went back through chapter 2 and solidified our notes and pushed that up. And then in this part 3, we're going to be completing the end of chapter practice problems and practice, exercises and whatnot. So hopefully it doesn't take us too long. And yeah, let's go ahead and get into here and actually write some C code for the first time in almost like 6 or 7, 8 months. I haven't actually written C code since like January or February of 2025. So it's been quite a while. So please bear with me. I am trying to learn and be transparent with you guys here. So if I mess up, I mess up, but I am trying to learn and get better here. All right, here we go. Number 1. We're going to do this. Create and run Kernighan and Ritchie's famous Hello World program. Okay, so we're gonna have to we're gonna follow this layout, but I'm going to try my best not to look at it for right now. All right, so to set this up, we need to first include the standard io.h header file library with our include directive. We are then going to have a main function which returns an integer and has no parameters. We're going to open up this main function with braces, not colons, right? And we are going to call printf. We're just going to printf, right? And what we're going to print is the string hello world. And then we have to give the \n in C as well, and put a semicolon here. And I believe that this will be our program in its entirety. Let's check. Conclude standard IO, int main void, printf hello world, \n, nice. All right, so let's see if we can compile this. CD chapter 2. CD chapter 2 exercises. What? Exercise. Oh my gosh. Not doing it. Okay. Now we want to so the thing is if I want to get onto this file here, do I CD onto the file? Or I don't think so. I rarely use the terminal to do this. I'm trying to get better. It's not a directory. So how can we just like get our terminal to open this file? Oh, I just need to run it, right? Because we're in this directory. Okay. So we just need to do, let's go up to our notes, to our compiler here. And I think we're on this, we have GCC compiler in our Mac here. So let's do GCC -O Chapter 2 exercise 1.c. No input file. Oh, I don't want a -O. Right? Because why? Okay, can someone tell me why my terminal is doing this? It's like really annoying. What is going on? Trying to figure this out. We've never really had to compile C code in our IDE here before, so this is a first for us. So let's do this, GCC just our file here. Okay. Okay, now we get this a.out. Yeah, so that gives us a.out. And now do we just double click on this a.out file? Let me see. How to run a.out file. /a.out. Ah. Hey, let's go. Let's go. We got it here. Okay, so now, but if we were to do this, but call chapter 2 exercise 1 oh, and then we need the -O, right? GCC -O. Okay, and now we get an executable file here. And then if we go chapter 2 exercise 1. Ah, there we go. Do we plan on finishing the entire book? Heck yeah. We're going to try at least. I always get distracted about halfway through and move on to a different book. Okay, cool. Nice. We got it. We got it. Nice. That's cool. I'm happy we were able to do that. Okay, nice. That is pretty cool. I'm going to move this terminal down here. Come on, how do you do it? I want to move this entire thing, like, here, there we go. Okay, now it's better. Okay, we got this. Okay, exercise 1 done. Let's go ahead and throw this into a its own directory. So chapter 2 exercise 1. And then we need to rename this guy. I spelled it wrong. Oh, you can't. Huh. Exercise. Okay, something like that, I guess. We'll just throw that in there. Okay, cool. Let's go chapter 2, exercise 2. Moving on. Exercise 2. Let's open up a file here. Let's use our terminal. Let's go CD chapter 2, CD chapter 2. Chapter 2, exercise 2. CD into chapter 2 exercises. CD into chapter 2 exercise 2. Okay, here we go. Now let's go touch. Okay, here we go. Alright, let's try this one out. Consider the following program. Boom. Identify the directives and statements in this program. Okay, so, I'm going to copy this, or we'll write it. Consider the following program. Right, and then let's write this. So we want to include the standard io.h. We want int main with no parameters. And we are going to open this up and do these print statements. So I'm going to actually copy these. I don't really want to write these out. Oh, brutal. Kitty, stop scratching the couch. Come on. I fed you already. Cat's being bad. Yo. Okay, and then fill the time. Probably should have just wrote it out. Probably would have been faster. Okay, Parkinson's law, work expands so as to let's kind of just get the formatting right. Available for its completion. Okay. Nice. All right, cool. So we're going to identify the directives and statements in this program. A. Identify the directives and statements, and B. What output does the program produce? Okay, so I'm actually going to use the this guy. Okay, here we go. Nice. Hey, Eduardo. Yeah, we're getting into some C programming. We're really trying to learn this one here and get some good practice. All right, identify the directives and statements in this program. We'll do directives are the following. So let's go back to our notes. Remember that directives, declarations, directives, commands intended for the preprocessor prior to compilation. Always begin with the hashtag character, one line long and no semicolon. So the only directive in here is to include standard.io.h, right? And then the statements. Let's go back here. A command to be executed within the program when the program runs. Return and my function. Okay, so statements. So you have directives and statements, and obviously, always is main considered a statement? Where was that one example that we had of kind of like that just that boilerplate here? Wanted to see it. Where was it? Here we go. Declarations and statements. So declarations are what you assign like your variables for, and then your statements are things that you want to like have happen, right? So your statements are like these guys. Your print statements, printf, and return. Right, so those are our statements within our overall function. What output does the program produce? Print a Parkinson's law. Work expands so as to fill the time available for its completion. Okay, so let's go ahead and run this program. Exercise 2. So let's, how do you go back? So opposite of CD. CD hyphen. Chapter 2 exercises, okay. So CD chapter 2 exercise 2. And then let's go GCC-O. I need to rename this real quick. Chapter 2, exercise 2. We'll do chapter 2, exercise 2, exe, chapter 2, exercise 2.c. Okay, and then if we do this, chapter 2, exercise 2, exe, there we go. Parkinson's law. Work expands to fill the time available for its completion. So what does it print? It prints literally this. Nice. All right, that was problem 2. Moving on up. Chapter 2, exercise 3. Hey, Foaz, how's it going, my boy? Welcome back in. Okay, chapter 2, exercise 3.c. All right, we have this program here, so we're going to want to this is condense. I don't know, hopefully it won't screw up the formatting. Okay. Condense the dweight.c program by 1, replacing the assignment to height, length, and weight with initializers, and 2, removing the weight variable instead of calculating volume within the last printf. Okay, let's go to our dweight.c program from earlier. Fahrenheit to Celsius. This is dweight2, dweight.c here. So this computes the dimensional weight of a 12 by 10 by 8 box, right? Cool. So we want to condense this program. So let's go include the standard io.h. We are going to int main void, and we're going to open up this function. Okay, it wants us to replace assignments to height, length, and width with initializers. Height, length, and width to initializers, and 2, removing the weight variable here. Instead, calculating volume within the last printf. Replace the assignments to height, length, and width with initializers. With initializers. Okay, so it wants us to initialize them all in one. Okay, got you. So we're going to do int height, which is going to be equal to 8. Length, which is going to be equal to 12. And width, which is going to be equal to 10. So that initializes all these lines into one single line. Remove the weight variable instead of calculating volume plus 165 divided by 166 within the last printf. Okay, so we're going to keep our other things. So we're going to do printf, and we're going to printf the dimensions. We're going to insert our integer here for our length times percent d width times percent d height backslash n for a new line. And we're going to insert our length, width, and height variables into here. Cool. And then what we'll do is we'll do a semicolon there. We're going to print f for the second line and do volume in cubic inches, right? We're just formatting strings here. We're going to insert our integer value of volume into here, right? Oop. Which we need to create and instantiate. So we're going to int volume is going to be equal to our height variable times our length variable times our width variable, right? Now, hey, who's that? Doom, thanks for the sub. Appreciate you. Hey, Lance, thanks for coming in. Hey, Doom, thanks so much for following and subscribing along here. We're almost 6 subs away from 3,600, so moving on up. I appreciate the love and the support. Yeah, we're learning C here. My name is Michael. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I've been teaching myself computer science and programming for a little over a year and a half now, mainly through mediums of Python at the moment, but now we're transitioning into learning more about C and trying to dive deeper into just computer science and like hardware and things like that, and getting to know more about the computer in general, so, and how to interact with it. So I'm excited to get into some more C here. We're getting some practice with chapter 2 of C Programming, a Modern Approach, 2nd edition here by K.N. King. So thanks so much for being here. So we'll do dimensional weight, right, and then in pounds. And what we're going to do is we're going to insert our percent D variable, right? And they're going to \n. And what we're going to do is we're going to directly reference mathematics or expressions within the printf statement. So we're going to do volume plus 165 divided by 166. Like that. And I did my parentheses like this just to keep it clean. Now what we're going to do is this. We also need a semicolon here. I always forget those semicolons. Now we're going to return 0 here. And then let's see if we can get this output. So we're in chapter 2, exercise 2. So let's CD out of here. Let's go chapter 2, CD into chapter 2, exercise 3. Let's go GCC, chapter 2, exercise 3, EXE. We need a -o here. Right, that command to give a file name besides a.out. And then what we're going to do is call the actual file we want to compile, and link is the exercise 3 .c file. Alright, we have an error here. We need a semicolon at the end of this. We have undeclared identifier. We have an error typo here. My bad. Let's try this again. Alright, we compiled. Let's go ahead and call / chapter 2 exercise 3. Oop, we need a colon. Dimensions 12 by 8 by 12 by 10 by 8, 960, and dimensional weight in pounds 6. Sweet. That worked. It's kind of hard to see because of the chat, so I'll bring it up here and show you guys. Oh. There you go, guys. Nice. All right. Can I ask, hey Larry, how's it going? Can I ask where you got that PDF / book? I would love to get a hold of it to review. Yeah, I've just looked it up online. It's C Programming, a Modern Approach, 2nd edition. Like the Internet Archive has it, or I have a link to it where I'm sharing it kind of in a like a Google Drive, whatever, in my GitHub, where I have like all of my resources that I use, kind of like a roadmap of everything I've done for free, just in there. Everything I've been using, books that I've read, videos I watch, I'll throw in there just to have it all be one general location. So feel free to join the Discord link down below and get in there and be a part of the community and get access to all the resources and stuff. So yeah, All right, that was exercise number 3. Let's go ahead and keep it pushing here. Chapter 2, exercise 4. All right, let's go CD out of here. Let's go CD into chapter 2, exercise 4. Cool. Now let's move on. Cool. We want to open up a new file here called chapter 2 exercise 4.c. Okay, this is going to say, we'll use the other comment. Okay, write a program that declares several int and float variables without initializing them and then prints their values. Is there any pattern to the values? Usually there isn't. Okay, it says write a program that declares several int and float variables without initializing them and then prints their values. So we don't want to initialize. Okay. So I think it's trying to show us potentially that we're going to get some garbage values potentially. So we want to write a program that declares several int variables. Okay, so we have our directive to include the standard io.h, and we're going to return in main void, right? And in here we're going to declare several variables but not assign them any values or initialize them. So we're going to have int, let's say name, age, and or not, no, we'll say int age and what other variables should we declare here? Age and I don't know, num. And then let's declare a couple floats of type let's do like cache. And then let's do like what would else be a float, like decimal, or like I don't know, what would be a small number, what would be like a, this is, come on Mike, this is not the hard part here. Cache, I guess we'll just do like temp. And then it wants us to print their values. So we're going to print age %d \n num %d \n cache %f \n, but we also, yeah, and then temp %f \n. Okay. Print f, sorry, and then that'll do that, and then, so that'll print all of those. Okay, so let's see what happens here. I don't think we're going to get any relation to these variables. It might just give us garbage. So we want to go GCC-O, chapter 2, exercise 4. -C. One warning generated. Percent conversions than more percent conversions than data. Well, we still compile. We got a warning though that the %D given here. Oh, we need to we have to give these age, num. Come on, Mike. Cache. Let's try that one more time. There we go. Now let's do / chapter 2 exercise 4 exe. Boom. So we get just garbage values basically. Right, and we'll say no relation, garbage values, due to no initial. Oh my gosh, INIT. What is going on? Initialization. There we go. No relation, garbage values due to no initialization of declared vars being printed. Cool. What's up, Mir? How's it going? Hey, Sec, how's it going? Sexy. I hope you say that C is greater than Python at the end of the series. Yeah, hopefully we'll find out, my friends. Stick along and we'll get to the general synopsis here. So far, I'm liking how Python is really great for just writing quick and fast things and getting some like using the power of those libraries and things that are other people have written to your advantage. So it's really good for that, and obviously for like my data science type of things and whatnot. So I'm going to be interested in what kind of projects that I get inspired to write with C now that if we can get more information on it here. So we're going to try our best. It's kind of hard. I need to move that chat. So let me move chat. Hold on. Move chat up here. I'll move chat up there. I don't want it to block the code though, but I don't want it to... I might have to move it up here. Yeah, we'll do like that. That's fine. Hey, Luke, how's it going? Whoa, you just came up on my page. I'm planning to be a chemistry major, and I'm also interested in learning C and programming. Nice, dude. Yeah, welcome. Yeah, I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I make and manufacture biological controls that are used in like diagnostics and patients and stuff. I've been teaching myself computer science and programming for a little over a year and a half. Made some pretty cool chemistry and biology related projects such as spectroscopy simulations, chromatography simulations, business and accounting tools. I've implemented a tool at my work for automating and computing linear programming model for a chemical matrix theoretical yield to give us better results and reduce mathematical times that we have to spend doing hand math. And yeah, it's pretty cool. So far we've done a lot and trying to see how far we can go with this. All right, let's go on to exercise number 5 here. Let's keep it pushing. I might shorthand these I don't know, these chapter 2 exercise. I'm spending a lot of time just typing out file names, which is kind of annoying. because I'm having to do a lot of like terminal work here, so by having long file names is kind of frustrating. Chapter 2, exercise 5.c. Okay, let's code this. Let's do this. Exercise 5. Which of the following is not legal identifiers? This one's pretty easy, so we can just, we don't think we need, we don't even need to write any code here. A, B, C, 100 bottles. Let me retake this. 100 bottles. Bottles by the 100. Okay. So which of these identifiers is are not legal identifiers, right? This is which one of the following are not legal identifiers? Okay, so there's one that's illegal. So this is 100 bottles. It's this one right off the bat. It's A. So this one's illegal because you can't prefix the start with a number. Right? I think that was one of our rules. Let's check our notes. Yeah. The number comes after. It's A. The numbers in identifiers are allowed, however, they are not allowed to be used as a prefix. Right? What do you guys think? I saw that you watched the Harvard lectures. Was going to do that, so are they worth it? Yeah, I think that they're definitely worth it. I just personally have more of a difficult time learning by lecture. I find myself in my brain wandering. I don't know. Like I really try to focus, but if I'm not like super engaged in exactly what that person is saying, like at that moment in like in terms of like a one-on-one conversation, it really kind of doesn't like super hit home with me. I don't know why. Like I really much better about sorry, let me rethink here. I'm much better at obtaining the information and through text, like and just practice. I don't know, there's something about watching a lecture and over video that I just get distracted, and my mind end up wandering about different stuff, and by having to do this, you can't move on through these problems without reading them. And so like the lecture gives you kind of this false kind of hope where, oh, if I just finish the lecture, I have like obtained the knowledge, whereas it's not really true. Like in order to get through the questions here, you have to actually like read the words and to understand. There's no like watching and just kind of, I don't know, I feel like there's a different type of effort that goes into it. I might be crazy. All right, cool. That was exercise 5. Let's move on to exercise number 6, chapter 2, exercise 6. Open a new file, chapter 2, exercise 6.c. Okay, why is it not a good idea for an identifier to contain more than one adjacent underscore, as in current balance, for example? Oh, interesting. This has more than one adjacent underscore. Let's go up to our talk on identifiers. Layout identifiers here. begins with the symbol, begins with a digit, not a letter. Must begin with a letter or underscore. And may contain certain universal character names as well. Yeah, so the 10 out front is not allowed in this case. But why is a good idea not a good idea? Current balance. Underscore as in current balance. So, okay, it's not illegal, but it's a bad idea because it may be difficult for a reader to interpret how many underscores there are in the identifier, in the repeated sequence, repeated underscore sequence. Right. Anybody have any other good ideas why they think it's a good idea not to do 3 underscores back to back to back in identifiers? What would be another good reason? So it may be difficult for a reader to interpret how many underscores there are in the repeated underscore sequence, right? It's difficult to really do that. That's probably the main one. I'm going to take this. I'm going to ask here. Let's see what it says. To elaborate, using multiple adjacent underscores is discouraged because readers suffer ability or error prone in naming. Gotcha. Cool. Absolutely. Who was that? Hey, so that's Boing Black. Thanks so much for the sub. Spacewalker, thanks so much for the sub on YouTube. I appreciate you as well. You're awesome. Okay, nice. Let's go ahead and continue on with our next exercise. Chapter 2, exercise 7. Chapter 2, exercise 7.c. Okay. For which of the following are keywords in C? Okay. We're getting some easier ones here. Whew. For capital IF, main all lowercase, printf all lowercase, and while all lowercase. Okay. So are these not, is it just if? Because it's capital? If is a keyword in C, but keywords are case sensitive. If does not equal to if. Nice. That one wasn't too bad. Let's try chapter 2, exercise number 8. And let's do chapter 2, exercise 8.c. Cool. Let's get caught up on a couple more chats here. RJ, someone tell me what's going on. Hey, we're learning C by reading C Programming: A Modern Approach, 2nd edition. It's a book that's taught in many readers read to learn C in kind of a modern age. It's a little bit dated, but it should have the information, pretty relevant that we need for at least beginner level C and, learning these fundamentals. And then hopefully we can write some cool projects later on. I want to get into more hardware stuff and see if we can maybe mess around with a Raspberry Pi or Arduino or something. And yeah. Thank you guys so much for being here. Appreciate you guys so much. Microcontrollers, industrial control. Yeah, exactly, microcontrollers. There are small problems that might be able to fit multiple in one file. Oh dear. Good luck with C. Hey, Insertia. Appreciate you. Hey, King Glur. How's it going? King Glur, like the Pokemon? I've seen reserved keywords like underscore, DCL spec that have double underscores. You also run into the risk of identifiers clashing with things provided in the compiling toolchain. Yeah, thank you so much. Good info, everybody. Good info. Appreciate everybody for being here. If you could throw a like on the stream, it's completely free, and I'd really appreciate it. We got 30 people in here. Appreciate you guys being here. It's not boring. No, we're having fun here, someone. We're having fun. I'm having a good time. Having a good time. All right, let's get into number 8. Again, these notes and these answers can be found in my GitHub repo, linked down below, if you would like to also study along with me. Okay, so here we go. How many tokens are in the following statement? Okay, so how many tokens are in the following statement? Remember when we talked about tokens was this idea that tokens are kind of like anything regarding these. Right, yeah. So tokens are groups of characters that can't be split up without changing their meaning. So right, this is going to be a token, right? If you split up answer into a space, that's a different meaning, right? That's a different variable, or in itself, that's like that's a bug, right? So this is a token here. One token. We have obviously punctuation and operators. So token 1, 2, 3, 4. So tokens are operators, punctuation marks, and string literals. 5. Well, hold on. What is... Let's go back down here, see what this looked like. So it was just some math. 3 times P. Yeah, 3 times P minus... 3 times Q minus P times P. Divided by 3. Okay, so now you can space these out and the expression remains the same. So this in itself is not like a string literal, so it's not all a token. So this is a 1 token, right? This is 1. This is 2, 3. This would be 4, 5, 6. Now, because these are the same variables, are these repeating tokens? Or are these new tokens just because it's a new character, like in our expression here, but it's a repeated character? So then we'd have like 7, 8, 9, 10, right? 11, 12, 13, 14. So 14 potential tokens. What do you guys think? Not like ChatGPT tokens. We're talking about tokens as in like identifiers, keywords, operators, and punctuations are all tokens. This was a string literal, that's why it's all a token in itself. Okay, let's see here. Let's get some verification. What do you guys think? I'm going to bring this off to the side, but I won't spoil it. What do you guys think? Before I say it, I'm going to say, before you spoil, I think let's do 1, 2, 3, 4, 5, 6, 7. Now, is the semicolon a token? That's the only thing I might be... Yes, the semicolon is a token. It's punctuation. So is it 14? Yes, contains 14 tokens exactly. Cool. Let's go. Okay, cool. Let's go. Chapter 2, exercise 9. Ooh. Chapter 2, exercise 9.c. Okay. Bro, you're a legend for learning streaming. Keep going. Trying my best here, Emphatic. Thank you so much for the support. I appreciate you so much. You're so kind. Okay. This has a W here. What does W mean? I forgot. Okay, let's copy this in. Okay, insert spaces between the tokens in exercises 8 to make the statement easier to read. Oh, that was easy. Okay, whatever. Let me do like... Let me open this up. Let's do this. Right. So we have to also declare that this is going to be an int. Or is that inferred by the math happening here? I have a question. Does this... Do you have... Oh my gosh. Oh. Yes, so you have to declare int into the answer with P and Q here, or by itself in the line. Cool. Alright, now last exercise. Chapter 2, exercise 10. Let's go chapter 2, exercise 10.c. Okay. In dwait.c program in section 2.4, which spaces are essential? Okay, so let's go up to our dwait.c program here in section 2.4. Here. All right, computes the dimensional weight of a 12 by 10 by 8 box. We include standard IO.h. I don't think we need a space here. Oh, we might actually, because the include needs to have a space in between the statement here. So that space is needed, I believe. Well, let's see here. Let's go like... Now if you do... Yeah, that's not the same thing as this. Or is it? Oh, it is. It is. Okay, so that space is not needed. Then let's see, like int main void int height. So you have to have a space for the height, I think. length, width, volume, weight, height equals to 8. Okay, yeah, so this is kind of, something's happening here, obviously. Int main void. Have to put this on a new. Maybe. Interesting. I want to see, there was that one program we saw at the very beginning in chapter 1 for like really difficult programs that are possible. I want to see here, right? Okay, so they do put their, you do have to declare your can you just do this? So main is obviously not being detected here by the IDE. If I were to go like this, still not. There you go, now you get it, okay. So main does have to be on its own line here. Now can we combine this? Yes, we can. So the IDE likes that, lets you do that. You have to give a space here for all these variables. And then you can maybe start doing some math here. Where'd it go? Okay. C99 removed implicit int, and Node recommends using a compiler that only targets C89 and before. Oh, interesting. C99 removed the implicit int in main, so you can get rid of this. Okay, in C99. Got you. But it won't hurt to have it. So height 8 still gets declared here. Now if you say width or length equals to 12, width equals to 10, volume is equal to height times length times width, and then you can, then I'm guessing you can do all these other statements, right? So I think I have this. Didn't we do this already? Yeah, here. Take these statements just to save me a little time. Print F here, print F here, and then you can return 0, boom. And I think that this will run the same exact way, right? So if we go and do CD back out of here. Let's show CD into chapter 2 exercise 10. Oop. Let's go CD, or let's go GCC-O, chapter 2 exercise 10 exe chapter 2 let's see. Okay, now we do // chapter 2 exercise 10 exe. Boom. Nice. So we were able to remove all of this into, you could, if you wanted to, cram it into a single line and see, because the difference with C and Python is you have these these ending characters, right? So that is something I didn't realize, that you have this ability with these specific delimiting characters for the end of lines, right? Is you can really cram your code, if you wanted to, into a lot more confined line space, because you're declaring when the specific statements are over, as if you were saying, okay, I'm going to a new line in Python, right? Now, whether you want to do that or not, that's up to you for whatever purposes you're doing, I'm not sure. But you just have that option to do like multiple line, actions with this kind of delimiting character of the semicolon in these types of languages, right? So interesting. Second edition is from 2017, supposedly. Vintage aesthetic. Why not place things on separate lines? That's just the purpose of this specific problem. It's just trying to show you that that most spaces aren't essential. So the spaces that are essential, we'll say spaces that are essential are within string literals. After a variable declaration, like int, float, etc. And what other string spaces? That's pretty much it. And then directives need their own line, right? Let's get some feedback on this guy. You're very close. That's the right idea, but let's clarify which spaces are essential in the program. Technically, C compiler ignores most white spaces, but spaces are essential for the program to read correctly. Spaces between keywords and identifiers, between directives. The space between include and standard IO is essential. Well, actually, it's not really. It's kind of reading it either way here. Interesting. Please put spaces before I reach. All right, we'll put a space here. Hey, thanks for the sub. Who was that? Guardians and Dokugan. Appreciate you so much for the subs on YouTube. You guys are awesome. We have crossed over 3,600. What's the website I'm learning from? This is not a website. This is a book, C Programming, A Modern Approach. We're in Chapter 2, finishing up the end of Chapter 2, Practice Problems. You guys, I read this chapter completely out loud, audiobook style on the stream, and then chopped that up to like a channel video. So go back and you guys can watch that, whether you're in traffic or just in the car or in your headphones. It's really good to just have on, throw on for 30 minutes in the background and listen to the chapter and get some solidified information. Just get another pass over the fundamentals. I think it's really good. Or you can directly follow along with me in the book if you would like, and then we're just going through the entire books like we've been doing, learning and doing the practice. So cool. That was the 10 exercises at the end of Chapter 2. So we do have, it looks like 8 practice projects here, which don't look like they're that hard. So let's go ahead and see if we can dive into these. So let's do let's go open up a new terminal here. We'll go git add, and we'll commit here. Remember, you guys can find these practice problems and notes on my GitHub, link down below. Finish, or we'll say complete Chapter 2 exercises. All right. All right, cool. Let's go ahead and get into these Chapter 2 programming projects. Chapter 2 programming projects. Chapter 2 programming project 1. .c Chapter 2 programming project 1. Okay. Write a program that uses printf to display the following picture on the screen with a check mark made out of stars. Okay, so the thing about this problem is that we have not been introduced yet in the book to for loops. So we are restricted, I believe, per just what we've been given, to the current utilities that we have, such as just printf. So I'm going to literally call, I think, printf for every row in this without the use of a for loop. So just bear with me, I'm not using a for loop just because we have not been introduced to for loops yet. Okay, so let's go ahead and do this one. Include the standard io.h, and let's go int main. Let's do void. Open up a main function here. So we have 1, 2, 3, 4, 5, 6 rows. So we're going to do 6 rows of prints. How do we want to do this? Right, so we could use our tab delimiter or our tab, special character to give us some spacing pretty quick rather than just doing a bunch of spaces. But whatever, let's just try some stuff. It's kind of a crappy, it'll be kind of ugly, but it's whatever. All right, so we want to do, let's do 2 tabs. No, let's maybe not do tabs because tabs are what, like 3 or so spaces, and we'd have to know exactly how many spaces per tab. It's a little bit more math that I'm really wanting to do right now. So let's just keep it simple. Let's just do, I don't know, how many spaces is this? 1. This is space in between, so 3 characters. This is 5 characters. So it goes up by 2 every single time. So 7, 9, 11 spaces, 11 characters. I mean, I could use some math here for the space, but what do you guys think? This problem's kind of funny. I've learned that tabs are evil after C++. Yeah. Number of spaces per tab is entirely predicted. Yeah. Probably shouldn't use tabs then. Let's just do spaces then. 1, 2, 3. I don't know. I mean, let's just do fillers and then we'll get rid of the fillers. So let's do like dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we'll get rid of this one for here. Here. 3. And then on this one, you do a guy here, and you do, I'll come back to that other guy. Here, and then you do here. I mean, we might have 1 too many spaces here, it looks like. It might be easier to start out from the bottom and go up. Let's try that. So this is just a single character, and then Here we're gonna do this and then a space and then this. But we're gonna need new lines, right? Or should we just do what uses a single printf call? Should we just use a single printf call? Okay, and then here we would go new line, and then we do star 1 2 3. Oh, why is it doing that? 1 2 3 star back, and then we do. This sucks. How do you keep track of all these spaces? This problem is kind of annoying. So this is. I can't even highlight the spacings here. We might have to brute force it and just try it out. So this is 5 characters. So this is obviously gonna be 7 characters. So 1 2 3 4 5. 1 2 3 4 5 6 7. Like that. New line. 1 2 1 2. Oh, why does he keep doing that? Nine, and then new line. This is so ugly. 1 2 3 4. Oh, come on. 1 2 3 4 5 6 7 8 9 10 11. Let's see if that works. Oh my gosh. Don't judge me on this problem. I think that's what we're supposed to do, because we haven't learned loops or anything, and I don't know, it just seems kind of ugly. Let's go CD into chapter, or no, we had this guy here already. Let's go out of here, out of here. How do you keep going, not back and forth? Because I just went back and forth. How do you go, like, just into, go back and then keep going back to the root? CD chapter 2, CD chapter 2 programming projects. And then we're going to do GCC-0, or sorry, no, chapter 2, programming project 1. Oh, hold up. Hold up. We need to go into... Oh, no. I had it right. Oh, come on. We want to do GCC-0 or -0. Chapter 2. Programming. Project. Oh, I am in there. Oh, come on, dude. This is so annoying. I guess this is my one thing I'm starting to get annoyed with about C is all of these commands. Python is pretty easy. Hit the play hit the play button. Hit that play button. Let it run. Chapter 2 programming projects. We need to go programming project 1 for chapter 2. Yeah, I gotta redo these naming. This is crap. I gotta rethink this. Okay, now we go and do GCC, this guy here. Now we do / chapter 2 programming project 1 exe. I don't even have a 1 there. Ugh. What? No such file directory. Chapter 2. Oh, I spelled it wrong. It's programming, I guess. I guess I'll rename this. Oh my gosh, dude. This is rough. Okay, we're close. We are close. There's not a space here? Oh, there is a space. It's just really small. But this got 1, 2 spaces. And this gets... But we have spaces on... Oh, that's right. There's going to be 3 spaces to the left of this guy. There's going to be no spaces to the left of this guy. Alright, let's try that. No dice. So we'll compile and then we'll run. Programming. Oh. Yeah, that's right. We need to go up and fix this. Programming. Oh boy. Okay, so we have... Uh-oh. Okay, so we need to fix this a little bit. So we have there. Then obviously we need... If this is our terminal, we have 3 spaces. Or 2 spaces in that. 1, 2 spaces. And then the star. Okay, how does that look? Okay. Now we'll spread out this guy. By 1 more space. Weird. Why does that have just 1 space? This goes there. There we go, right? And then we want to have this guy go in 1 space to the left here, which means that this also has to go in 1 more space to the right here. And then we need 1 more space here. And then I think we have 1 too many spacings on these guys. Am I trolling? What's going on? Why is this so much harder than I thought it was going to be? Now 1 less space here. All right, I think that's our answer. Okay, so what do we have to do? This was 1, 2, 3, 4, 5, 6 spaces. 1, 2, 3, 4, 5 spaces. 4 or 5 spaces. Oh, 6 spaces. So this is 1, 2, 7. Okay, 7, 6, 5. Then 3 with a singular out there. Space. 2 spaces, but with that one there. And then 2 and then a singular. Interesting. Okay. Yeah, I think it's yeah, it was adding a double after double space it was doing period. Tab in the terminal, make it autocomplete file names. Oh, sweet, we'll have to try that. Okay, that one was annoying. All right, whatever. The check mark is done. All right, let's move on. So we want to go into here and do chapter 2, programming exercise, or programming project 2. Open this up, chapter 2, programming project 2.c. All right. Yeah, 88. 88 just showed us, he just did it with multiple print statements. This is just with one print statement. All right, cool. Let's go ahead and move on to our next problem here. Write a program that computes the volume of a sphere with a 10-meter radius using the formula volume equals to 4 over 3 pi r cubed. Write the fraction 4 over 3 as 4.0 float over 3.0 float. Try writing it as 4 over 3 with integer division. What happens? C doesn't have an exponential operator, so you need to multiply r by itself twice to compute r cubed. Oh, twice, yeah, right, not by itself, once. Twice. Twice would be squared, once would be squared, twice would be cubed. By itself, twice. Okay, so this one's pretty easy. I'll say that now. Include the standard IO .h. Let's go int main void. And let's go ahead and get into this. So we have a int r, which is going to be equal to 10. And then we have float volume is equal to volume is going to be equal to 4.0f over 3.0f, right? Which will give us a floats for this specific, expression portion. And then we want to do times pi. How do you call pi in this? They didn't show us that. I mean, I could just do 3.14f, right? But is there, I mean, I don't want to do stuff it didn't teach us yet, but is there a header file that, has pi in it, like a math? Right? We didn't learn about, what's the name of the C programming book? This is C Programming, a Modern Approach. by K.N. King, second edition. You can find a copy of it in my Discord link down below or just online. It's pretty easy to find. Right, so this word, we can declare pi here. Math.h has pi in it. Yeah, chapter 2 did not talk about math.h at all. So I don't want to use anything that's not talked about in the chapter yet. Right? Okay, so we could people say usually is a directive, right? So we could add a directive and use that in here. Okay, we'll just keep it a variable for now. I just don't want to do anything that doesn't. I don't want to jump the gun on stuff in the chapter yet. I know we know what to do, but okay. Okay, cool. So now we need to compute this volume. So volume is equal to, or we'll say, sorry. This is going to be a float. Is going to be equal to, oh no, we have volume already here. Sorry, this is our, times our pi value, times, and then what we're going to do is r times r times r here. And so then if we print f, we'll go volume or sphere volume. We'll do radius equals to 10. And then what we're going to do here is do %f \n and put in the volume value here. And then we're going to return 0. Right. So now if we cd into chapter 2 programming project 2 and do GCC programming project 2.exe. Oh, we need a semicolon here. Now if we go / programming chapter 2 programming project 2.exe, sphere radius is this. Cool. Now I could do 0.2 f here and recompile this and get a float rounded to 2. Perfect. Woo! All right, what do we think about that? What do we think about that? Nice. All right, let's keep it pushing. Chapter 2, programming project 3. Chapter 2, programming, chapter 2. All right. ChatGPT says it's better to use a const variable instead of defining a macro because you get type safety and all that. Oh, that's interesting. Right, that makes sense, right? Because when you define pi as that, you don't get. Do you define when you do macro definitions? Do you define type in macro? Okay. Number 3. Modify the program of programming project 2 so that it prompts the user to enter the radius of the sphere. Ooh, that's a good exercise. All right, here we go. We'll take this guy, and what we're gonna do is we're gonna call scanf, and we're gonna do enter sphere radius, and then I'm going to do this, and I'm going to capture this value scanf. We had to insert the variable where we want it and capture that into an integer. So enter radius, and we're going to do %d here, right? And then we're going to capture this in R is going to be here, and then radius goes away, or no, do we need to declare? Well, we need to save this in memory, so we have to do this ampersand R, right? That'll save it to the place in memory. And then, but the thing is I don't have any declaration of R. So do I need to say still int R here? Or do I say int R is equal to this scanf call? Yes. So int R, right? And then you ask for this scanf. You compute this value given your reference of R. So we declare the variable. We save the response to this within our location in memory. And then we dereference that variable and perform operations on the value of R. This one's a little bit trickier. Let me look up my scanf here. It's not of a pointer type. So we don't have to dereference this R here when using it. Or do we have to dereference the R? Okay. Let's try it here. So let's go GCC Chapter 2 Programming Project 3 exe and Chapter 2 Programming Project 3.c. Oh. CD into Chapter 2 Programming Project 3. Let's compile. Okay. Expected after the expression here. Indirection requires pointer operand int invalid. Okay, so if I just take these off, what does that give me? Okay, that compiled. Okay, this isn't asking for any text in scanf. We got bad stuff going on here. Okay, so scanf isn't displaying this text at all. Sphere volume, radius 10. So this would be radius of %d. We would put R here, and then volume goes to there. So obviously we're not getting the correct radius in there. So if I were to run this again in J10, yeah, this radius is not getting picked up here. So it's scanf isn't displaying any actual input here. Would you have to use this in combination with printf? Oh, you do, right? So you do, I forgot about that. So you do printf. It's not like input where it's combined. You just do printf. Then you would say enter sphere radius. Sorry. Then you're here. Then you have scanf like that. And then you print out this. So scanf is saving Fahrenheit here. We have Fahrenheit saved here as float. So scanf returns a float type, not a type of int, because it's scanf or scanformf. But it looks like you're declaring Fahrenheit of a float in this example here, and then using scan. Oh, but you're getting %f, so you're actually declaring it as what you're receiving it as, right? So this would go to R. I'll make this radius. Let's just make this longhand so we get confused here. Right. So now we need to figure out why this math is not happening appropriately. So they don't have to dereference this ampersand radius. Is it because we're doing float operation on against a integer? There we go. Okay, why did it work that time? So that's what we wanted. Scanf doesn't take a string for that. Yeah, I was thinking more of, I was on the lines of Python input function rather than scanf. So the scanf you have to put in combo with your printf, right? And then use the scanf. So I'm guessing in the Python input function, it uses the printf and the scanf in combo under the hood, written in C, obviously, right? To do that in Python. Cool. See, this is what I wanted. I wanted better understanding of what's going on in our Python, so I can write more fluent, better, better Python code, and translate that into C and understanding what's going on, and also be able to write in C as well. This is good. It takes a pattern string, not a print string. Got you. Okay, so now what would happen if we removed the float values like it said here and did just that? Right, so it's a different number because it's significant. It's heavily influenced. It's truncated downward. Right, so we're leaving off all of that tail of 4/3, and that skew is causing us to actually decrease by almost a factor of a fourth. Hey, sorry about that, guys. My dog will be barking. Cool. Learn Leaf code. Python is the only way. Okay, cool. That was nice. Okay. How long have we been going for? 2 hours? It's 8:30. Okay, I'll try to see if we can finish this up in half an hour. Chapter 2, or programming project 4. We'll do chapter 2, programming project 4.c. Okay. CD into chapter 2, programming project 4. There we go. Okay. Write a program that asks the user to enter dollars and cents amounts, then displays the amount with 5% tax added. Okay. Write a program that, okay, so we're going to include the standard io.h. We're going to go int main void, and we're going to open this up, and we're going to ask the user with a printf function to enter dollar and cent amounts. Enter dollar and cents. Right? So the thing is it's not. I'm getting a little bit too overkill because I'm thinking, okay, how do we clean the user input? How do we make sure it's clean and whatnot? But we haven't really learned about too much of these features yet in C. So we're kind of just, it's pretty much kind of more basic. So enter dollars and cents, or should we say just enter dollars? Right. And then we'll do scanf. And we're going to look for a float value. right? And we're going to save this within a value of money. And I'm going to call float money here. Then if I say we want to print f with tax added is here, and we're going to do %f. We're going to compute a value here of money times 0.95, or we will add onto this no, sorry. We don't want to take away 5%. We want to go 0.05 and then add money back onto this. Right. So we're going to take money, multiply it by 0.05 to get what 5% of money is, and then add that back to money. Or we could just take money itself, actually, and just multiply it by 1.05. And then we would probably want to float value around this to 0.2, right, to keep it into monetary value, money. Yeah, let's try that. We're in programming project chapter 4. Let's compile this. 4. And let's do this. 4. Let's do 100.00. 105 with tax added. Cool. And then we just need to add in a \n here. Nice. And then also a $sign. 1050. Go. Haha, let's go. Easy. Why are you doing this as a biochemist? Just for fun. Learn more skills, keep myself... I found that I didn't really want to learn more about biochemistry and chemistry. Honestly, I don't really have that large of I don't really want to keep going down that path. I'd much rather learn about computer science and stuff, and get more information on a different subject in science, because I've been really interested in computers all my life and I wanted to learn more. Just never really had an opportunity, I guess, and now I'm going to just take the opportunity myself and do it. So I'm going to learn more about computers here, and it should be fun, and I appreciate you guys being here and hanging out with me. Yeah. Yeah, I was wondering about sanitation of the user input here, right? But we don't really get into the specifics of how it wants it. It's kind of more it's pretty open-ended, right? Enter a dollar and cents amount. So you could take back to and then you can format it how you want it into float. Oh, okay, yeah. Or you could do this, right? So scan F, and you could format it as this, and then do and dollars. and cents, right? And then you could do money equals, well, that'd be float dollars and cents. And then you'd have to how do you save this though? This saves these two values as dollars and cents. But how would you save the entire thing? Right? If you do this, how do you save the entire thing in a float money var? Or you dollars and cents, and then you just add dollars plus cents, and then you divide it by 100. To make money. Interesting. You would take dollars and cents and make money, right? But why do you have to do this inside of the scanf? To separate? Because it's kind of like a regular expression. You're expecting a decimal place in there, and to save the left and right values into these. But then what if you don't get the decimal place? You just default into the prefix. If you want to read something like 12.34 from input and store in a single float, you can do it directly using this, like we have here. Or you could take money equal to the dollars divided by cents, or sorry. Right, and then do that. Interesting. Then you could take money, put it into there. So if we did it this way, and if we enter in and then it does it too. So you can do it either way here. Okay, cool. Write a program that asks the, okay, let's go to, keep pushing here. Chapter 2, Programming Problem Project 5. Chapter 2, Programming Project 5.c. Okay. Write a program that asks the user to enter a value for x, then displays the value of the following polynomial. C doesn't have an exponential operation to multiply by itself. Okay. We're going to include the standard io.h header file. We are going to write int main and void, and we are going to open this up. We are going to declare a variable, int x, and we are going to call scanf, and we're going to do a decimal point D, or sorry, a decimal value, or sorry, a digit value. And we're going to save this in the memory location of X. We are then going to call, we're going to do a print statement, right? Say enter value. Enter X value. Right? We'll do that. And then what we're going to do is we are going to call printf here and a result. Result here, and we'll put in a %. Now, do we want to do a integer value? Let's do a digit. Yeah. And we'll put in this. So we'll say result is equal to, and we'll put in this expression of 3 times 3 times %d times %d times %d times %d times %d, and then we're going to do, so that handles that one, plus 2 times right, %d %, so we'll do 4 of these. Right. And then we have less than 5 times %d times %d times %d. Now the thing is am I going to have to insert this X value like a gazillion times for all of these things, right? I'm curious. We're going to find out. So then here, if we have just x squared, this will just be less than %d times %d. Then we have plus 7 times %d. Then we have less than 6. So this is within this value here. So I would actually just do, oh, whoops, sorry. I didn't mean to do, I thought it was in the print statement. So let's do %d, and let's swap this out with x for now. Let's just do this. And then I will do right, so we're going to enter the x value, and that will be here. We're going to save this in x. We're going to do 3 times x to the 5th, 2 times x to the 4th, minus 5 times x to the 3rd, minus x squared, plus 7 times x, minus 6, and then we're going to print out our result here. So let's see what we get with this. Okay, let's try it. 5, 5. Oop, we gotta go back. CD into chapter 2, programming project 5. We'll compile and we will do this. Enter X value, 5. Result, 1004. All right, let's, I think that's right. If we do 0, we should just get -6, right? Nice. All right. Amira, how's it going? How's it going? How's it going? All right, that was that one. I think we're good there. Let's see. Let's catch up on some chats. Hey, hello from Argentina. Nice. My friend from Argentina just discovered your channel right now. She wants to begin programming. Thank you. Nice. Awesome. Just discovered your channel right now. She wants to begin programming. Yeah, that's super cool. I appreciate you joining me and learning programming alongside me here. I got a lot of great resources linked in my Discord down below, completely for free. Everything I've been learning so far in there. Yeah, it's been a great building projects live in Python on stream. Now we're diving into some C. All right. Nice. Moving on. That gets the job done. It's chapter 2, programming project 6. Chapter 2, programming project 6.c. Modify the program from programming project 5 so that the polynomial is evaluated using the formula this. Note that the modified program performs fewer multiplications. This technique is evaluating polynomials known as Horner's rule. Remember, we learned about this rule in our Introduction to Algorithms book, I believe, as well as DSA in Python. It talked about how you can reduce polynomial multiplications to this kind of format as well. Okay, so let's go include inches. Include the standard io.h library here, and we're going to go int main void. And we are going to hey Lapta, how's it going? Int main void. Let's open this up. And then we're going to do something similar to this previous example. But instead of doing this long result here, we're going to do something different. We're going to do this. Okay, so now Python, you can't just do multiplication by like just the parentheses like you can in Python or in CME or like whatever. So you probably have to add in these values here, or can you just do parenthesis times parenthesis, like it's inferred that way too, like in math? Or do you have to keep to open the parentheses like so here? So what happens if we were to compile this? 6. Oh, CD, chapter 2, programming project 6. Uh, 5. Okay, good. It gave us the same values. And then 0 should give us -6. Perfect. Polynomial want a cracker? That's funny. Okay, cool. So again, I don't think you can do like this math in Python like or in C like this like you could in Python. Like I don't think it'll work like that. No. Right. Okay. Nice. Okay. Next problem. Chapter 2, programming project number 7. We're almost done. 2 more. Let's CD out of here. CD into chapter 2, programming project 7. Okay, here we go. Almost there. Chapter 2, programming project 7.c. Okay. Write a program that asks the user to enter a US dollar amount and then show how to pay that amount using the smallest number of 20, 10s, 5s, and $1 bill. Okay, so it wants us to basically give change. Without looping. Hint, divide the amount by 20 to enter the number of $20, then reduce the amount, yeah. Okay, so we're gonna have to do this without modulo, right, and without loop. That's fine. No modulo, no loop, that's okay. My headphones are dying. Let me go ahead and plug them in real quick. Sorry, let me plug them in. Give me a second. I'll go ahead and keep the music going though for you guys. I just can't hear it. Fireball. They usually let devs go and hire overseas Indians because they'll do it cheaper. Hey, Tomatic. Yeah, we're progressing into some C here. It was a very long time ago. I used to watch your stream. You were learning Python. Yeah, we are still learning Python, obviously. We have kind of like an intermediate fluency in Python and still expanding as we read, books like Fluent Python, DSA in Python, etc. But I wanted to dive into C as I wanted to understand what was going on behind the scenes in my Python code. I don't think that this is going to really deter me from learning Python. I think this is actually going to enhance my Python abilities because I'll be able to understand, what the functions in Python are actually doing under the hood, what kind of C code is being written and used under the hood, within them, and write my own C programs and maybe my own C packages to then import into Python, right? I think that would be cool as well, and we could really go down that path. Missile Lab is coming because of the adverts, but is it math that can be accelerated by GPU or NPU? What? I don't know. Okay. Almost done. Let's keep pushing. Okay, so we're going to include the standard io.h, and we're going to run int main void for our main function. And we are going to have a printf statement to get values from the user. So enter a dollar amount. And then we're going to have this be received, right, as such. And we're going to do scanf to receive back the value that they sent. And we're going to save that in amount. And then we need to go to the memory there, right? We're going to have int amount be here, declared. And what we're going to do is say 20s is equal to our amount divided by 20, right? That'll give us how many 20s we can actually make out of this dollar amount. We're going to do amount. Can you do less equals in C like this? By 20s. And then we're going to do 10s is equal to the amount divided by 10. And then we're going to do amount less equals the amount, or the 10s. Then we have amount. We have 5s is equal to amount divided by 5. And then we have amount less equals amount. And then we just have the amount left over, which is 1s, right? And then we need to declare some variables here. So we'll have amount, 20s, 10s, 5s, right? And then we're going to call printf, and we're going to printf to $20 bills is equal to a %d \n, $10 bills %d \n, $5 bills %d \n, and then $1 bills and %d \n. And we're going to put into here, for the first one, 20s, 10s, 5s, and then the amount left over. So $20 bills will be the 20s, the amount gets updated. The $10 amount gets the amount of $10, and now it gets updated. And then the $5 is the amount divided by 5, and the amount gets updated. And then we print the in display in this format here. Right. Cool. Okay, let's try this. So this is going to be programming project number 7. Number 7. Okay, that compiled. Good. 7. Let's do 96, or 93, sorry. 4, 8, 16, 0. No, okay. So I wonder if we have to say amount less than 20s, and then amount less than 10s equals to amount less than 5s. Can you not do in place? And then we give amount. Oh, I'm done. I'm not going to look at chat. I'm not at chat. So we're going to do amount is less than the current amount. So less than or equal to, amount by the 20s. We have to multiply it by the value that we are right. Oh. Okay, here we go. I have to figure this out. So we have to do the amount by 20. No. 20, this, not amount. I'm so dumb. This is by 20. This is by 10. And this is by 5. It's the amount of 5 by 5 minus amount. I think, right? Let's try that. 93. Ah, yeah. We're not dumb. We're not totally dumb. You guys are probably screaming at the screen right now. All right, cool. Got it. Right? We had to multiply the value that we received by the factor that it was factored down by to get that total and then reduce it by the amount. Right? Cool. All right, that's that. Boom. All right, last one here. Chapter 2, Programming Project 8. Chapter 2, Programming Project 8.c. Oh. Okay. There you go. You never wanted to deviate into cloud ML side before? Okay. And C in turn has to produce the equivalent of assembler. This makes me want to do a bit of coding. Yeah, go for it, man. Take this opportunity while I'm coding to sit down and do some coding right alongside me, right? Hold yourself accountable and get some practice in. All right, last one here, you guys. We've been going for 2.5 hours. So if you guys have enjoyed the end of Chapter 2, C, Programming and Modern Approach, 2nd edition, end of Chapter 2, Practice Problems, exercises, and programming projects, please give a like to the stream. I've been sitting here on my Sunday practicing some code for you guys and for myself. Thank you guys so much for being here. I appreciate it so much. Okay, last one. Home stretch. Write a program that calculates the remaining balance on a loan after the first and second and third monthly payments. So enter an amount of a loan, enter the interest rate, and enter monthly payment. The balance remaining after the first payment, the balance remaining after the second payment. Display each balance with 2 decimals after each point. Hint, each month the balance is decreased by the amount of the payment, but increased by the balance times the monthly interest rate. To find the monthly interest rate, convert the interest rate to users to percentage divided by 12. To find the monthly interest rate, convert the interest rate entered by the user to percentage. Okay, this one's a little bit harder. So we're going to include the standard io.h, and we're going to run int main and void, and we're going to open this up. We're going to have a printf function for enter amount of loan, right? We're going to have a scanf function for enter interest rate, or I'm sorry, Oh, this is going to be printf, right? And we need to have that scanf here. And we're going to look for a %f, and we're going to save this as amount. And we're going to have a float declared for amount above. Okay. We are going to then do another scanf for the float value that you gave for the interest rate. Right? And we're going to have this be rate. Right? And enter monthly payment. So we're going to enter the monthly payment, which we're going to have another scanf to look for that input, and we're going to %f for the, this will be the payment. And what we're going to do is save that to its memory location. Cool. So we have 3 prints and 3 scans. All right. Display each balance with 2 remaining decimal places. Okay, so we want to compute the balance remaining after the first payment. So each month, the balance is decreased by the amount of the payment, but increased by the balance times the monthly interest rate. So we're going to do monthly rate, which is going to be a float, is equal to this. We're going, monthly rate is equal to the rate we currently have right? Okay, so is it going, if we have to enter a 6% rate, so a float rate, so it'd be, okay, so we rate times 100, right? We'd multiply the rate by 100 to convert it to its percentage, and then we would, well, they're entering a 6.0 rate by itself. So they're not entering the converted, they're entering the percentage themselves. Enter interest rate, and they're putting 6. So the user is entering a interest rate as a percentage, given by this example. So actually, the monthly rate is just the rate divided by 12, right? It's just the rate divided by 12, because if they're entering it into whole percentage, or into percentage, well, we'll get the percentage per month. So that'll give us the monthly percentage rate. And then the month 1, right, month 1 is going to equal to month 1 balance is going to equal to each month the balance is decreased by the amount of the payment. So we're going to have the amount less than the payment, right? Each month, the balance is decreased by the amount of the payment, but increased by the balance plus the balance, or the amount, plus the monthly rate times the monthly rate, right? And then this is going to be float, monthly balance, month one balance. And then if I copy this down and do month two balance, is the month one balance less than the payment plus the month one balance times the monthly rate. And then the month three balance is the month two balance minus the payment plus the month two balance times the monthly rate. Now we print F for balance remaining after first payment, and then percent 0.2 F, and we're going to put into here the month one balance. Copy this down twice, put in the month two balance and the month three balance, and we'll change this to second and change this to third. Right? Oh, that's right. I'm forgetting some returns here in these previous functions. I forgot them all. Dang it. Come on, you gotta remember that. Return. I forgot it here too. Man, I forgot it everywhere. Y'all didn't remind me. Come on, y'all. There we go. I'm gonna blame you guys. I'm blaming you guys. Okay. First, need to delete code for coding interviews. This dev gave me motivation. Nice, emphatic. Yeah, that's the whole point. If you guys are wanting to study but are struggling to set aside the time, consider just hopping on stream, putting on the stream in the background, and hanging out with me with some programming going on in the background, so you can kind of keep that that spark going with what's going on and relevancy to me learning programming, and then also just doing whatever you're doing on the side, and working on your projects and just holding yourself accountable, like as like a group session here. Hey Darius, welcome in. Welcome. Okay. Cool, let's go ahead and go and compile this. Number 8, last one here. You guys are enjoying this last one here. Leave a like on the stream, I really appreciate it if you could. If you guys are new and want to subscribe, I stream almost every single day, me teaching myself computer science and programming after my 9-to-5 job as a formulation chemist. I have a degree in human biology and a minor in chemistry, and I work as a chemist where I manufacture biological controls that are used in patient diagnostics. I've been actually, using code at my work more and more that I've been teaching myself. My company's giving me permission to write code for some projects to formulate and compute automatic yields for theoretical concentrations of a dimensional or a multidimensional matrix array of serums, and to produce like a blend of these serums. And actually was successful in writing a linear programming script for that. and with another person, and it was really cool. I wrote like a whole interface using Tkinter and stuff, and we're going to start implementing it soon on our next go round of manufacturing, and yeah, it's pretty cool. All right, let's compile this. Ah, we got an error. Need this guy here, this guy here. There we go, compiled. And let's try this, number 8. Enter the amount of loan, we want to do 20,000. Interest rate of 6. Monthly payment of 386.66. Oh, we forgot our \ns here. Dang it. Oh, we do have some problems here though. It's a month too. Okay, so monthly rate is this. The amount times the monthly rate. Amount less than the payment plus the amount times the monthly rate. And then the month 1 balance left over is it like order of operations? Some issues going on here. All right, we're getting some problems here. So our month 1 balance plus the amount. Oh, it's not the amount times the monthly interest rate. We're not adding on the amount and the monthly interest rate. We're adding on the monthly interest rate. Oh, 6%. 6. Right, we're taking 6% and multiplying it by the amount. Okay, so then we need to do... Yeah, we have to do actually 6 divided by 100.0f divided by 12. Right, we need to take the rate and divide it by 100. And then divide that by 12 to get this, I think so. 20 grand, 6%, 386.66. Yeah, let's go. Nice. All right, let's add in just some $signs here, and that'll be it. $20 grand. Interest rate is 6%. Monthly payment of 100 or no, 386.66. There it is. Nice. So after 3 months, you'll have paid off $1,000 of your car almost. But there's an automatic return on main. It will compile. Yeah. It talked about how it'll kind of silently throw an error, but it will compile if you don't return. But it's good practice to like do it right. All right, you guys. Woo! Nice. Round of applause. Round of applause. That was super awesome. That was actually like a lot of like work. It wasn't like very hard. It really wasn't very difficult at all in terms of the types of problems we're doing. The problems were very, very easy, just simple arithmetic and whatnot, variable declaration and such. But it just helped us to get used to writing the overall kind of flow in C. Like if we're kind of not having to think about what's like too hard of problems, like I like that I use these kind of easier problems so I don't have to also think about what's going on in the problem and learn the code, right? I'm not trying to solve a leap code problem while trying to learn C. I'm just trying to solve some easy problems in C so I can really focus on the syntax, focus on make sure I'm getting my the syntax and all that, structured right, organized, written clean, and then we can start ramping up the problems more and more and more. So this was the end of chapter 2. So I really appreciate you guys joining me for this part 3 of the chapter 2. In the first one, we read the entire chapter. In part 2, we went back through the entire chapter and solidified our notes. And in part 3, we completed the exercises and the post practice problems or practice projects. So thank you guys so much for joining me for today. We streamed for 2 hours and 45 minutes on this Sunday, October 26th. This was super awesome. We are going to be getting into chapter 3 next, formatted input output. So more stuff on formatting strings with the printf function and scanf, as well as diving deeper into C functionality. So if you guys are enjoying the stream and enjoying learning C alongside me, please subscribe and join me tomorrow and future streams. Please like the stream if you guys are doing so, because it really helps YouTube to keep pushing our content out and keep promoting it. But yeah, this was super fun, and I'm really glad that we were able to do this. I will see you guys tomorrow. Please let me know if you have any questions. Let's go ahead and push this up though. Git add. You guys can find all of these notes and practice problems for this chapter and reading on my GitHub, link down below, as well as me reading the actual chapters, these recaps in videos on my channel, as well as in the streams, right? We do it in the streams. So finished chapter 2. All right, chapter 2 is done. We completed all 10 exercises and all 8 programming projects, as well as took some really nice chapter 2 notes. So if you guys want to go through and get these practice yourself, please do so. I highly recommend it. This was awesome. I'm feeling a lot better in C, like in general, like in terms of like, obviously we have a long ways to go, but just from where I was starting and syntax wise and comfortable just like writing basic programs, I'm feeling a lot more comfortable doing so. Obviously using the compiler, using these certain flags like -o to modify the compiler and do whatnot, and actually running the compiler GCC. So thank you guys so much for hanging out with me. This was a lot of fun. Yeah, ChatGPT definitely could solve this one. It solved a lot harder problems than this, from my experience. It was these are just simple problems getting help practice with the actual code. But I mean, I've given ChatGPT some of my problems to look at, like for like stock analysis. It's been able to solve them basically. So yeah. All right, you guys. Sorry, I keep yapping here, but I'm gonna go ahead and head out tonight. Make sure you guys subscribe, please. I'll see you guys tomorrow. Thank you so much. Fireball, Brutal King, SS Low, Abdullah. Thank you so much. Lapta. Who else was in here? I can't go too far up in the chat. Emphatic. Amura, shout out you guys. 88 Pockets, Patrick, Slow, Raul, Karan, obviously Tim, Wakata, Insertia. All you guys are clutch. Thank you guys so much for the help, and see you guys tomorrow. Have a good one. Message